All right, lesson 99 brings us to our favorite uniform motion. Now should be the last kind of example of uniform motion that we're going to learn. So this one is unequal distances, I believe. I believe that's what it is. Yes. All right, so let's look at A here. All right, now you understand kind of the idea behind these. This is, to me, the most difficult, but also in some ways it's easier because you understand the idea. So once you kind of get good at writing down all your variables, writing down all the stuff you know, these become, tolerable. All right, so let's read A. At 5 a.m., Napoleon headed south from Waterloo at 4 kilometers per hour. At 7 a.m., Wellington headed south from Waterloo. If Wellington passed Napoleon and was 20 kilometers ahead of Napoleon at 2 p.m., how fast was Wellington traveling? So they're both traveling from the same place. They're both going south. Napoleon is going 4 kilometers an hour, and he starts at 5. Okay, and we want to check their, we're getting a check of the speed, but we're checking it at 2 p.m. So at that point, Napoleon had driven from 5 to 12 is 7 plus 2 more hours. So he's driven 9 hours, and Wellington has started at 7, so he went 7 to 12, just 5 hours plus 2 more. So he's driven 7 hours. So one drove 9 hours, one drove 7 hours, okay? And then Wellington, the fast one, is 20 kilometers ahead of Napoleon. So he's passed him. All right, so let's see what we can do with this. So uniform motion, unequal distances. So at first I just write down a bunch of what I know, right? So the distance of Napoleon is equal to R of n, T of n. Distance of Wellington is equal to R of W, T of W. I wrote when they started driving. I also wrote that the time of Napoleon is equal to Wellington plus 2. Remember, Napoleon started at 5. Wellington started at 7. So Napoleon is driving or riding 2 more hours than Wellington. So I wrote that up. Okay. Oh, it says the rate of Napoleon was 4 kilometers. That was, right? Let's see what else I wrote here. In orange, I just drew a little picture down here. The distance of Napoleon plus 20 is equal to the distance of Wellington. Because remember, Wellington passed up Napoleon. They all started from one spot. I should have maybe driven it from south to north or whatever it was, but I drove it from here. This guy starts, Wellington speeds past him, passes him up, and then down here at the end, he's 20 kilometers ahead of Napoleon. So that's what that drawing's supposed to do. Sometimes my drawings are more confusing than helpful. So you don't have to do that if it's unhelpful. All right, so then over here in orange, I wrote distance of Napoleon plus 20 equals distance of Wellington. And then I substituted the R of n, T of n plus 20, R of W, T of W. Okay, and then I started to substitute some more stuff in. So I have 4. Let's see, somewhere I wrote, oh, there we go. My green marker. The time of Napoleon is 9. We went through that a little bit. And the time of Wellington is 7. So I started plugging some of this stuff in. And then the rate up there is 4. Okay, so I wrote 4, which is the rate of the time of Wellington plus 2 plus 20 is equal to the rate of Wellington times 7, because we knew that time was 7, right? Okay, and then I went ahead and I plugged in, we had the rate of Wellington was 7 plus 2, as I determined up here, or the time of Wellington is 7 plus 2, right? So I added that together, and that gives me 9. 9 times 4 is 36. Plus 20 is equal to 7 RW. So 56 after I add 36 and 20 equals 7 RW. Divide both sides by 7. And the rate of Wellington is 8 kilometers per hour. Okay, so that's that one. Let me give you a minute to look at it all. Okay. All right, and then the next one. So I go back to reading. Okay. Helen has a 4-kilometer head start on Paris. How long will it take Paris to catch Helen if Helen travels 6 kilometers per hour and Paris travels 8 kilometers per hour? Okay, so somebody has a head start. Helen has a head start, so she's ahead. And so then Paris is going to start joining in. And how long will it take Paris to catch Helen if Helen travels at 6 kilometers per hour? Okay, so when we set that up, we have Helen. Okay, she's running. She has a head start, right? And so that's plus 4, I think. Yeah, 4-kilometer head start. And then Paris starts running. I don't know why I have them running to the left, but they are. And we're trying to figure out whether we're going to catch up. So distance of Paris, rate of Paris, time of Paris equals rate of Helen, time of Helen plus 4. Because there was that head start, so Paris had to catch up. Okay, it said there, let's see this other stuff that it said so we can remind ourselves. I always define all the stuff I can. It says that the rate of Paris was 8. The rate of Helen was 6. And also the time of Paris and Helen is inferred to be the same time. Because they're, unlike the last problem, they're starting at the same time. It's just like she's given a head start. Maybe she was like a baby or something, or a young child. So she's given a head start. That doesn't mean they're starting at different times. So the time is the same. All right, so we come here. 8 times time of Paris equals 6 times, I go ahead and write time of Paris since they're the same. I just substitute the other one in, plus 4. Okay, subtract the 6 TP from both sides. 2 TP equals 4. Divide both sides by 2. The time of Paris is 2 hours. So it took 2 hours to catch up to Helen with her head start. Okay. All right, I'll be back with 101 shortly.